Welcome to the Nemal Electronics presentation on composite cables for HD broadcast. My name is Ben Nemser. I'm the CEO of Nemal Electronics. We've been designing and building composite cables since our customers first started asking for them over 40 years ago. In fact, many people are not even aware that composite cables exist, or what they are, or how you can get them. Today we're going to answer some of those questions and hopefully provide some valuable information. Our topics of discussion today include the system concept approach, what is a composite cable, where and why we should use composite cables. We'll look at some of the typical composite cable subcomponents. We'll look at some of the termination options for those components. And then we'll look at some of the various jacketing options. When we talk about system concept approach, we're talking about the ability to bundle a wide range of various components in one very neat, easy to manage package, a composite cable. This greatly facilitates interconnecting equipment, identifying cables, keeping things neat and organized, and in fact, preventing damage to your existing cabling structure. What is a composite cable? Basically, we can define a composite cable as a combination of different cabling components under one jacket. That jacket might be extruded, or it might be sleeved, or other means of holding those components together.
Static cable actually is a compact version of multiple SMPTEs in one jacket. In this case, Stadium 4, this is a plenum jacket, so it can be pretty much run anywhere, consists of 4 subsets of electricals and 4 subsets of glass. So you have 8 pieces of glass here and 4 subsets of electricals. It occupies much less space than 4 full-size SMPTE, and the cost savings can also be figured in. The advantage here is this can be dressed out to discrete modules. The electricals are paired with 2 pieces of glass. They would go to the back of an independent module, such as this, or a rack full of them, such as this. 2 discrete pieces of glass to a multi-pin CPC connector, then out to camera connectors. The advantages are predominantly size and weight, as well as cost and ease of installation. This can be terminated pretty much by any telecom or data communications person. You don't actually need lessons in SMPTE termination, as you're basically going to put on whatever the mating connectors are, Frank Charlie, Sam Tom, Sam Charlie's, APCs, whatever, fusion spliced or direct termination. This can be dressed to multiple different types of connectors. Our connector of choice, of course, is the CPC, circular plastic connector, that allows the use of a back shell. And of course, the fact that it's plenum allows it to be run in any of the venues without concern for not meeting building codes.
Where and why should we use composite cables? This is actually a big question, goes to the heart of this presentation. We have built composite cables for a wide range of applications. Every day someone will ask us for something that we hadn't even considered previously. But some of the more common uses are, for example, in audio and video systems in broadcast facilities, for instrumentation, control, studios. Some of the larger cables we've built have in fact been for a network news desk. 20 to 25 different components, all routed from a control room to a desk in a very neat and easy to use fashion. What are some of the typical composite cable subcomponents? There are many. Basically, we can divide them into categories of video, audio, data, power, and as a subcategory, they can be either copper or fiber optic. We'll look at these more in depth later. A composite cable, as we mentioned, can be any combination of these audio, video, data, fiber, or power components in different numbers, in different colors, and with different termination options. Pretty much the sky is the limit. We're looking here at a TechFlex sleeved composite cable, as opposed to the extruded jacket we're going to look at later. TechFlex sleeving is the ideal solution when you have a small overall length or a small overall quantity or a very large specific unique cable that wouldn't justify a full extrusion run. TechFlex is available in different colors, in different sizes. We've done cabling up to 2 inches in diameter, and you can mix a lot of different components, and in terms of cost provides the best option for smaller quantities.
Next, I'd like to discuss composite cables as they're put together in TechFlex. An example here, this is TechFlex sleeving over a pair of audio and 3 video. It's custom constructed. It can be fanned out in any dimension. The limit is pretty much just the diameter. I can give you an example here. This is actually the precursor to a composite cable consisting of several Cat6s, several SDHDIs, a couple of power cords, and multiple mic audios. This was sleeved with a wrap. Wrap differs from the standard sleeving, as this is basically wrapped around the core of this. This allows you to build composite cables in very small lengths and very small runs versus a custom extruded jacket, like often found in the SMT or broadcast composite cables. You'd have to run several thousand feet in order to make sense of it. In this case, you could do on this run as many as short as 50 feet, dress out to individual cameras. You could add power, you could add fiber, you could also change the color, as in this case, to match wood flooring. It's also available in your primary colors, but I would say that this probably constitutes the majority. Your blacks for your studios, your tans for your live sets. It's available in extremely large diameters to sleeve over products. However, maintenancing of it, so pulling one out or adding to it can make it a little difficult. But it does have that advantage of being able to be used in a low production run. Now, like I said, I've done them as short as 3 feet for individual cameras.
Along with composite cables, go composite panels. This is an ideal method of terminating a composite cable, building a custom panel with all of the different components just as you'd have in the cable. In fact, it really provides a clear view of what that cable would be. And it is interesting to note that one cable can power a panel, completely supply signaling to a panel as complex as the one you're looking in the slide. This in fact is a representative panel of what you would find in a modern broadcast facility today. You've got a mix of optical con fiber in the upper left, MTP on the right, Cat6, BNCs for video, Type F for RF systems, XLRs for audio, DT12 for multi-channel audio in the bottom right, and then finally a LEMO SMPTE, your camera positions, in the bottom left. So what are some of the typical video or RF subcomponents? We can start with RF cables as small as 1/10 of an inch, sub-miniature. We then go into our standard RG59s, and today these cables are available in either 3G or 12G options. We've got several sizes available: the standard RG59, above the mini, an RG6, an RG7, even an RG11, which is getting kind of large and kind of stiff, and then our flexible RG59. For other applications, we've got a whole range of 50 ohm coaxial cables. Some of the factors that we use to determine which coax would be most appropriate would be the distance that you're running. I like to point out with this chart, it is extremely important, critically important, that you use the system concept approach that we first discussed when calculating these distances. These distances are overall distances on a perfect day at a perfect stable temperature with one termination at each end and no severe bends and no other extraneous factors. In other words, optimum. We suggest that in making plans for which cable you're going to use, that you build in a substantial fudge factor, so to speak, so that you don't have an issue of a signal drop-off because you tried to stretch something to the theoretical limit. These distances vary drastically depending upon the data rates. We can look at the 12G data rates, which are even more extreme, a little bit later. In terms of fiber optic subcomponents, we have again a number of different choices. The first choice we need to make is it single mode or is it multi-mode? The next decision would be, do we want a distribution type 900 micron, which would work in an extruded jacket in a protected environment, or are we going to break out that fiber, in which case we would strongly recommend a 2 to 3 millimeter jacket for protection, and for even more extreme applications we've got tactical fiber, extremely robust, something that you could tie into a knot and pull and the light path would not get interrupted. And here we're looking at a comparison between some of the various options that we have for fiber. On the first column there, after the fiber type, you've got your single mode fiber. This is going to be the most common in broadcast applications today, also the least expensive and the highest performance. You can see various types of multi-mode fiber going from a 62 micron, which is the OM1, which is the old style but still around, to your OM3 and OM4, which are the much more common 50 micron cores. And you can see the improved performance as we go through OM4, and in fact there are even further enhancements after OM4. Again, depends upon the equipment you have and drastic differences in the distance limits for these fibers. We also offer tactical fiber, which would be multiple strands of typically a single mode or an OM4. They would be under a jacket with Kevlar protection, and that whole tactical fiber would be one element of the composite cable. Here we see in a slide the difference between a distribution fiber and a breakout fiber. You see the distribution here, those individually colored fibers are 900 micron. You've got that Kevlar protection, and then you've got a jacket over the whole thing. This is ideal for a protected environment if you're terminating into a multi-contact fiber connector, or you're terminating directly into a panel or a splice enclosure. This would not be good if you're going to be breaking out and going different directions with different fibers, as we see in the next slide. Breakout. We have the option of either using a breakout cable, where all of those fibers you saw in the previous slide are already jacketed with Kevlar strength member under that jacket, or we can use the distribution fiber as we saw it and just perform a breakout at each end, which means putting a strain relief, that black strain relief device you see there, and sleeve individually each one of those fibers. The distribution fiber is going to be substantially smaller, substantially lighter, substantially less expensive, and more flexible than the breakout fiber. Again, we need to look at, are we running a lot of distance or a little distance, and what are the options for you doing that termination labor at the ends. And here we're looking at tactical fiber, which we had mentioned is an option for our composite cable. This tactical fiber, again, could be single mode, could be multi-mode, typically 2 to 12 fibers, with 4, 6, and 12 being the most common. and it's going to give you a very robust performance and a lot of protection at the throughout the length of this tactical fiber in terms of environmental issues, temperature range, and so forth. Another option today would be a multi-fiber terminated in an MTP, and we would be using a 12 or 24 fiber. This would be a specialized fiber. This transmits massive amounts of data, and the MTP would be one of the termination options. One of the advantages is you're using a standard D size, in this case a Neutrik D size receptacle, which would then have a breakout to whichever type of discrete fiber connectors you use, whether they be LCs, STs, or the like. For our power subcomponents, again, depending upon the equipment that you're going to power, the distance you're going to run, our most common power components would be either a 16.3 for your lower current applications, even an 18.3 in certain cases. For the standard, a 14.3 is suitable in many cases, and then for a higher current draw or a longer run, you may want to go to a 12.3. So we would offer these either as fully jacketed power cables, and we make a extra flexible, we call them AV flex cables. They're made to the SJE/OOW standards, and we also offer loose conductors. The advantage of the loose conductor is that it's going to give you a much smaller, lighter, and lower cost cable as well. However, you need to consider your power requirements, any UL requirements, and what the suitability is for your particular application of having loose power conductors. But they could be, again, any one of these gauges from 12 or smaller. In terms of components for carrying data, we've got the standard Cat5, Cat6, stranded versions, shielded versions, stranded and shielded. And then we also have tactical versions. A tactical version would be most beneficial in a case where there's a long breakout at one or both of the ends of the composite cable. Tactical cable would not do you a lot of good if it's already in a jacketed portion of the cable. But for the breakouts, that's where those tactical jackets would offer a big advantage. In terms of audio, again, wide range of choices. The most common being a line level microphone, typical 22 gauge foil shield, braided shield microphone cables, star quad constructions, typically 4 conductors of 22 with a braided shield, speaker cables. Speaker cables could run anywhere from 2 conductor to 8 conductor in 12 or 14 gauge being the most common. And then snake cables, multiple pairs already under a jacket. Again, most beneficial if you're going to break out and go a long distance at one or both of those ends, where most of the cable is protected under a common jacket for part of the way, and then the ends may go, each component going to different directions, different racks, different equipment, and in that case, those jackets would be more valuable.
I'd also like to discuss breakouts, the length and labeling of these breakouts. A lot of people don't take these into consideration, but everything's going to dress much prettier if we are given specific dimensions, unless, of course, you build it yourself. In this case, I would say this would be a component configuration, and I remember the camera distinctly having the BNCs much closer to the base than the audio. Now you would have actually 2-dimensional breakouts. You'd have this one and the video being 6 to 8 inches shorter than the actual audio. Simple, napkin drawing would illustrate this, plus we could label these in any character that you choose. Since we're basically using a laser printer label, often covered with heat shrink, we can write you a book on there if you would like. But the length of the fan out is important, especially if you take into consideration fiber cables and their breakout. A lot of people assume that they want something long when actually you want only enough to do the job. The longer this is, the more potential you have for hang up or damage. If you believe you're always going to be existing in a 2-rack unit area, top to bottom or side to side, 1 or 2 foot breakout is more than enough. I've had customers ask me for 3 or 6 foot breakouts, and once I pointed out to them, are they really going to plug them 12 feet apart? Not likely, no. So it's something that needs to be taken into consideration before ordering. And then, as we discussed, labeling, how do you want it to be labeled, each individual one? If they're not color-coded, what would you like them to be labeled as per function? So it's just something to consider.
Now we're going to look at termination options for all of these different subcomponents that we've just spoken about. And as you can see in this slide, this is a typical composite cable that we built for one of our clients. You've got multiple audio lines terminated in XLRs and multiple video lines terminated in BNC connectors, all color-coded, as well as color-coded boots. We also offer various types of labels and shrink tubing and the like. In terms of video termination options, Type F for your typical RF systems, BNCs, and here we have a few different choices today. Our standard 75 ohm BNC would be a 3G BNC. We have also a UHD or 12G BNC version. There are now HD BNCs, which, as you can see, are substantially different in size from BNCs and do not mate with BNCs and do not use the same stripping or crimping tools as BNCs. But if you have equipment that needs an HD BNC, please look at it very closely, and we can certainly terminate your cables with that style as opposed to a BNC. And then mini DINs, another miniature type connector that has become more common in the high frequency world. We see mini DINs a lot in dense environments, back of racks, and this would be something typically that's you're going to use on a 75 ohm precision coax. We're looking at a typical termination again, XLRs, BNCs, color-coded with boots, and different genders on the connectors as well. The audio options in terms of XLRs would also include your standard XLR type platings, as well as the black with gold plated contacts. For data connector options, we can terminate our data cables in a number of different ways, the most common by far being with RJ45s. And then with RJ45s, we have the option of either using an EtherCon shell or just using a plain RJ45 boot. For a harsh environment where you are going to be plugging into an EtherCon receptacle, the EtherCon boots again give you a lot of protection, especially considering the fragile nature of an RJ45. It's plastic, you step on it once and it's history. Other options would be D-sub miniatures. They come in 9 to 50 pin, male and female. And then multi-pin options. Many different multi-pin options. For example, for a Sony camera control, a CCA5 would be a miniature 8-pin circular. And that would be a possible subcomponent in a composite cable running to a camera. You may want that, that remote cable line, the CCA5 type. We're looking at a terminated snake Cat6, 4 Cat6s with EtherCon shells. And again, these are the black EtherCon shells, very good for harsh environments. For audio termination options, aside from the XLRs that we've seen in the last couple of slides, There are mini XLRs, that would be the upper left corner, RCAs, which you see in the upper right hand corner, and then 2.5 millimeter plugs, 3.5 millimeter plugs, 1/4 inch plugs. All of those three that I've just mentioned are available in either a 2-conductor mono or a 3-conductor stereo. And then finally we've got the speak-ons and power-cons. Speak-ons primarily for your speakers, available in 2-channel, 4-channel, and 8-channel. For fiber terminations, we have the options of, first, the discrete fiber termination for individual fibers. We're looking at the 4 most common terminations that we use. You've got 2 that are metallic. On the left is the ST, which is probably the most common. On the far right, you've got the LC, which is probably the most common for dense environments. And then you've got the SC and the FC. They can be kind of confusing, so we like to use phonetics, Frank Charlie, Sam Charlie, etc. What is important to know is that 2 of these are metallic, 2 of these are plastic. The plastic are going to be much more fragile. If a cart rolls over it or somebody steps on one of these things, they're probably not going to work very well after that. You'll also notice that the 3 on the left have a 2.5 millimeter ferrule. That's the white protrusion coming from the front, whereas the LC is a 1.25 millimeter. Just a note, when you do choose these things, make sure that you have the appropriate termination tooling, cleaning equipment, and testing if required, because the 1.25 millimeter ferrules are going to use all of those things different from the 2.5. So we've got these terminations, and each of these connectors has boot options as well. Some of the connectors are available in ruggedized versions, such as a tactical ST. That would be a great option if you're using something outdoor in the field where it's likely to get abused. So these are all things you can discuss with us. We'll give you the options and you can pick what works best for you. We just looked at the discrete or the individual fiber termination options. Now let's look at some of the multi-contact fiber terminations. This can be any of the standard military types. The Amphenol T-Focus can be HMAs, can be hermaphroditics, which come in really handy if you forget to pull one end that you meant to pull the other end, because this type of construction allows you to mate either end with either end, if that's the only component at that end. So multi-contact for your tactical fibers or for any of your multi-fiber contact connectors. We're now looking at the Neutrik Optical Con family. This in fact is a Optical Con SMPTE assembly. We like to mention Optical Con just because it has become so common today in the broadcast world, in the AV, whether it be professional, which is mostly our applications, but even in prosumers. You'll find optical cons in a mixing console that some DJ may have in his basement. So a few points about optical con just to help pick which termination we would want to use on our composite cable, or in fact if we would even want to consider having optical con as a component in a composite cable. Optical cons are available in either fiber only, which would be the standard 2 or 4, or fiber plus copper, which would be the one in this slide, which is 4 copper contacts, 2 fibers, the SMPTE standard. There are also other versions such as medical, and there are MTP versions, 12 and 24 fiber as well. Optical cons available in single mode or multi-mode. We suggest that for general interconnect capability, versatile interconnect capability that you would want to have, for example, in a broadcast truck that goes all around the country to different stadiums, or in an ENG vehicle that would go to different locations on a moment's notice, and you need to be able to transmit different types of signals over 500 feet or 1,000 feet, and you're not always sure exactly what you're going to need to use it for, an optical con on a TAC4, for example, would be a great versatile choice. You could use one TAC4 in your composite cable, terminate it with optical con, and use breakouts at each end to give you 4 separate fiber channels. They could be 4 different fiber channels, or they could all be the same, and they could be interchangeable just by interchanging the adapters that you would use with the optical cons. A TAC4, for example, is very light, very small, not very expensive, and again, you could get massive amounts of data down a TAC4 with using A to V converters, media converters today. You can pretty much change any of the signals that you would use on copper into fiber, carry it 1,000 feet, and then convert it back to copper again.
The differences between a mass connect of fiber versus discrete fiber. In this case, you would have a nitric optical con quad connector. It gives you the ability to actually mate 4 pieces of glass in a single connector, and also has a dust cap and is extremely robust as it's tethered to the tactical 4. However, it must only mate to the receptacle that it's intended to. If you take this outside of your own venue and you would like to plug it in, you may find out that there are only STs available for termination of the glass, while a tactical 4 with a discrete breakout of individual ST connectors lends itself better for remote application when you don't actually know what you're going to be plugged into. In all likelihood, you will always find an ST receptacle. You may not always find an optical con. However, mass termination of fiber, such as your own road kits, actually is a lot more durable. This connector is extremely hardy. It's available as a 2-fiber, 4-fiber, up to 12-fiber, and now even a 24-fiber. However, 4 of these, you could probably get away with a budget of $100 per end. An optical con quad on each end is going to be almost triple that in cost. So if you're going to invest that kind of money, make sure that it's actually going to return it with ease of installation and long-term durability. There's definitely an advantage to this. You just got to make the money make sense in order to terminate with mass connect.
We're looking at a optical con duo. You can see that the optical cons use the standard D mounts that you find in all your panels, same as the XLRs. And again, the standard optical con line comes with this very rugged metallic cap. There's a spring latch. There are shutters that do a really good job at reducing the dust contamination, although none of these things are going to completely eliminate your dust. Nothing's going to prevent the requirement to clean these things all the time. The other point about the optical con is there is a light version, an L, which you will see in the market, not extremely popular. The L is not suitable at all for outside, but it's great for inside a protected environment. It's a plastic housing, and again, it is susceptible to damage getting stepped on. We see an example of a SEMTI adapter. Again, a SEMTI fiber cable is one possible component in a composite cable. We've made many composite cables for studios and for remote broadcast. That would include a SEMTI cable. Typically, it's a reduced diameter, a 7mm SEMTI, and we can terminate those SEMTI cables in standard LEMO connectors, and this adapter would allow us to convert those LEMO connectors to standard discrete fiber connectors, in this case such as ST. So great options. Again, when you've got a composite cable with these various components in it, it's typically going to get you out of a jam. It's going to give you options for signal transmission that you would not have with any single cable on its own. As we saw in the prior slide, the adapters for the LEMO SMPTE connectors, we make a whole series of adapters for Optical Con, whether they be SMPTE or fiber only. You can take those Optical Con connectors and you can break them out to pretty much any kind of standard fiber connector that you want. In this case, we have a receptacle breaking out to 4 tails. In the upper left, we've got an insert of a receptacle mounted in a box with STs mounted in the box. So pretty much any kind of option that you can imagine. So here's the magic involved in making these things, and it's a really interesting process, and I would like to invite each of you, if you ever find yourself in Miami, and it's normally nicer in the wintertime than it is in the summertime, but give us a call and we'd love to show you the plant and give you a tour. You can see some of this equipment that we've designed over the years to build these cables and why every step of the way has an impact on the finished product. This particular slide shows one small section of a planetary cabling machine, and what the planetary does is allows us to combine all of these different components. And you're talking about, in many cases, you take a steel strength member and you're combining it together with a fragile single mode fiber of 900 microns. You need specialized equipment to maintain the tension, maintain the rotation, and get those components to match up perfectly, and then we jacket them. So this is the die where the components are coming together in the planetary cabler. This would be for an extruded type construction. And braiding, again, another area of manufacturing that if you're not in this business, you would look at it and you wouldn't really think much of it. But in fact, you're looking at a 24 carrier braider. There are 12 carriers going clockwise, 12 going counterclockwise at a certain speed with a certain gear ratio, and each one of them is at a certain angle, and each one of those bobbins in this particular case has 11 strands of a 38 gauge wire. Any of you who have played with a 38 gauge wire know how big that is, not very big. So it's our job to make sure that all those strands, or 200 and some odd strands, all come together at the right angle, at the right dimension, and each one of those parameters that we have to adjust affects not only the cable size, the cable weight, the cable flexibility, the cable cost, but also the DC resistance. And for anybody using a braid, as many of us do, for a ground or any other electrical requirement, knows how important the DCR is. So just the fact that you read a spec and it says this has a 95% braid, this has an 80% braid, does not tell you, without reading the DCR, you don't know. They can be 95% cable, percent braid, can have a much higher DC resistance than an 80%, depending upon all of those other factors. This is our philosophy, quality control. When we make these cables, we realize how critical they are, and we also realize that if we're doing a cable with 25 components and one component is bad, the whole cable may be bad. So we take this very seriously. We do continual testing at every step of the process. You can ask us about the testing. You can request special testing as well, but we do all the standard sparks as well as tensile and elongation, insulation resistance, and you name it. A lot of stuff happens before this roll of cable or this terminated reeler shows up at your door. We talked briefly about TechFlex sleeving, and now let's look at extruded jackets. And the extruded jackets are usually the best option for any run that total use of close to 1,000 feet and up. Also in environments where there's going to be a lot of abuse, where the TechFlex may not hold up as well. So we can do these extruded jackets up to about 1.5 inches diameter. That would be quite large. Typically they're in the 1/2 inch to 3/4 inch range would be the most common. We can do these in any colors. We have a wide range of materials available. We can do any type of printing on them. So there's lots of options that we can discuss with you. So the most common jacketing materials that we use are going to be the PVC types, the polyurethane types, or the TPE types. TPE, TPR. TPR is really a part of TPE. I like to emphasize that each one of these types covers a wide range of materials. And one manufacturer may say we have a PVC jacket, another manufacturer may say correctly we have a PVC jacket, and they may be as different as black and white, not just in the colors but in terms of the performance and the specifications. So it's important to know with any of these, do you have a temperature rating? Is there a particular flexibility rating? Because each one of these materials has what's called a durometer rating, and that tells you how stiff or flexible it's going to be. The stiffness and flexibility are going to vary dramatically with temperature. So what's the temperature range that we're putting in our spec? And then there are all the other components, such as which one's going to be good for running across a road, which one's going to be more abrasion resistant, which is going to be good for oils, or even in aviation use, for example, hydraulic fluids, Skydrol. So many different variations, and we can choose whichever one is going to be best for you. As a general rule, the most common is going to be our grade of TPE or TPR. It is the best combination for most applications of flexibility, durability, temperature rating, and cost. For extreme environments, we typically would recommend the polyurethane, which is going to be more abrasion resistant. It's going to be substantially more expensive and nowhere near as flexible as TPR. However, in an application subject to UL requirements, polyurethane is not going to work because, unfortunately, a lot of the properties that make it great for harsh environment also make it not great for flammability. So it will not meet most UL requirements for indoor. However, we offer UL rated materials, riser version as well as plenum version for certain products, and these would allow you to get a compromise between your flexibility and your UL requirement. The UL requirement is not an option. If you need it, and you have to work with it. Now you're looking at what an extruded jacket looks like coming out of this crosshead. That's this piece of equipment we're looking at. It's going in the other side without the jacket, and it's coming out this side with the jacket. We use a whole series of tooling, tips and dies, and temperature controls and pressure and so forth to make sure that it comes out at exactly the right viscosity, the right speed, and the right temperature and the right diameter. Very interesting process. I want to thank you all for joining us today. We really appreciate the opportunity to make this presentation to you, and look forward to seeing you all in person at some point in the future.